on the Newton's second law. So from Newton's second law, what does the Newton's second law say? F equal ma, right? The F is resultant force. Okay, it is the net force. Now, let's say, suppose that we have an object and you push it here 5 Newton, and then you push it here 10 Newton, and the resultant force is, you take the difference, right? So 10 people push to the right, 5 people push to the left, you have the net effect would be 5 Newton to the right. So it has a direction, you have to give direction 5 Newton, right? That is our net force. Now, when you have net force acting on an object, what happened to the object? Based on Newton's second law, 如果你有 net force, 你就有 acceleration. Okay, so the box will accelerate to the right as well. So the direction of the acceleration and the direction of the resultant force has to be the same. This is the first point, remember. So we have a net force, F resultant, to the right, same direction as the acceleration. Now, if my force is 10 Newton to the left and 10 Newton to the right, what happened to the box? It is balanced, right? So 10 people push from here, 10 people push from here, going nowhere. So 0 resultant force. 如果你的 resultant force 是 0 的话，这样你的 acceleration 是 when you put in the equation 0 acceleration, you get 0 as well. Okay, now 0 acceleration, I want to make something very clear. 0 acceleration, is it at rest or can it be moving? 0 acceleration, is it necessarily to be at rest or can it be moving? You got two scenarios. One is it is at rest. Another scenario is it is moving at constant velocity, at constant v. Okay, recall back what you learned in your previous class. So at rest, acceleration 0, and if you're moving at constant v, that means your v is not changing. Acceleration is the change of v, right? So if your v is not changing, then it's constant velocity. Okay, so acceleration 0 does not mean it must be at rest. No. Let me give you an example here. Imagine that a ball is moving. Okay, you apply a 10 Newton force to the right, and then this force is a resultant force. Okay, this is the only force to the right. So this one becomes the resultant force, and it will create an acceleration, right? The acceleration is also to the right. Now, if it's accelerating, that means it is gaining speed. What if we have a frictional force here, and let's say that this frictional force keeps on increasing? That means at first it is 2 Newton, and then suddenly become 4 Newton, 6 Newton. As the frictional force increases, right, your resultant force will decrease. Okay, so you take the 10 minus whatever is the frictional force, you get the resultant. So if your frictional force keeps on increasing, 2, 4, 6, 8, your resultant will decrease, and eventually the resultant force will become 0 when the frictional force increases to 10 Newton. Okay, so when the frictional force increases to 10 Newton, your resultant force becomes 0, and what happened to the ball? The ball will continue to move. So here I will write two forces, 10 Newton here, 10 Newton here. Balance already, and then your resultant become 0, and then acceleration become 0. Now at this instant, does the ball stop moving? Answer is no, because initially the ball is already moving. Because initially you apply 10 Newton, right? It is already moving. And as it keeps moving, the frictional force increases until it balances with the 10 Newton force. And what happened to the ball? The ball is still moving, but it is not gaining speed anymore. So you can say that from here, velocity is increasing, and once the resultant force becomes 0, velocity stop increasing. Okay, velocity stop increasing. That means it's moving with constant v. So this is one scenario where when acceleration is 0, object could be moving at constant velocity. So the point of this is to tell you that when air is 0, it can be rest, it can be moving at constant v. Another example would be like free fall. Falling, let's say you jump out of a plane, okay? And then initially your speed is 0. The moment you jump out, your speed is 0. And then you start falling. The speed increases. As you keep, the longer you fall, the faster you move, right? Because you have what? Gravitational acceleration. Plus 10, plus 10, plus 10, plus 10. And if there's air resistance, then after some period of time, you will reach a maximum velocity that we call it the terminal velocity. Every single object has its own terminal velocity. That is the maximum velocity. Why there's a maximum? Because as you fall, there's what force pulling you down? There's gravitational force pulling you down, W, right? W equals to mg. And as you go faster and faster, there's another force, the friction, the drag. Okay, where does the drag come from? Air resistance, it could be water. Okay, you can think of this as like a huge pocket of air. You cannot see the air, right? It's invisible, but you can just imagine that this ball is moving through a very like a dense pocket of air. So there is going to be some resistance. Okay, and the faster you move, the greater will be the drag. So it's like you move in water is difficult than you move on the ground. So air resistance increases at one point, balance out with the weight. That is when your acceleration terminates. When your acceleration terminates, your velocity is maximum. That is where you move down at constant velocity. Okay, so again, acceleration link, constant velocity. All right, let's take the application of Newton's second law in different situations. Let's look at the first situation, the one, a very classical example of often they will ask this, okay, which is the lift, the elevator problems. Okay, now let's look at, let me write it here, call it the elevator. Oops. Elevator. Now, let's say you're standing on the ground. Okay. How many forces is acting on your body? Now, every time you analyze force, please remember these 5 types. F 等于 ma, mg, ftr， 可以把它写下来。这是这5种。每次你要 analyze force 的时候，你一直 recite 这个 list ma, mg, ftr, ma, mg, ftr. Then you label, okay, which forces is involved in this situation. First, we have mg, label on acting on the body of the person, right? And then because this mg is pressing on the surface, on the ground, and according to Newton's third law, action reaction, when you press the ground, what happened to the ground? The ground does not allow itself to move. If the ground does not allow itself to be pushed, it will react to it. Again, the ground does not allow itself to be pushed, and therefore it reacts. It reacts to the pressing. How it reacts? It reacts by pressing you back. Okay, so it's kind of like you slap a person and the person slap back you. Okay, it's action and reaction. Okay, whatever you do on one thing, it will do the same thing on you. So here you get this reaction force, R. Now you see here, you got R, you got mg. Which one is your weight? Which one is the weight that you feel? The one that you experience? The weight that you experience, your own weight. Is it R or is it mg? Many people will say mg because mg is weight, right? But you see, when you stand on the ground, right, you feel that something is pressing on you. What is that force that is pressing on you? The reaction. The ground is pressing on you. That's how you feel it. You get the sensation of your weight because the ground is pressing on you. So in other words, you are experiencing the reaction force. Okay? Your experience of your own weight is the reaction. And if the reaction changes, then your experience of your own weight changes. You see, in some cases, your reaction will change depending on the situation, especially in an elevator, when the elevator is moving up, down. Now, when your reaction change, because your sensation, your feeling of your weight is from the reaction. So if the reaction change, then you feel your own weight changes as well. That is why sometimes you feel you are weightless. That is sometimes you feel that you are heavier when you are in the elevator. When the elevator is going up, you feel you are heavier. Okay? If it's going down, then you feel you are lighter. If the elevator is falling, you feel like you're never touching the ground. Okay? So your experience of your weight is the reaction, and because the reaction changes, so the sensation also changes. Okay, next one. Now, we take the elevator and we separate into 3 stages. Okay, 那我把这个擦掉先，你可以拿一个 screenshot 还是什么，然后我去 next slide。Okay. Now, in an elevator, let's say here, we separate this into 3 stages. First, let's say the elevator starts from ground and it goes up. Now, first stage is, I'll take the middle one as the first stage. Okay, so when it's on the ground, it's going up here and then at the top here. Suppose that the elevator at first it accelerates. So A acceleration is a positive value. Okay, there's acceleration and the V is increasing. And in the middle, there's no acceleration. That means the elevator is moving at constant velocity. And then the third stage up here, elevator is decelerating. Okay, it reaches the floor and then it decelerates. So acceleration is negative and then the V decreasing. Okay, 3 conditions. Let's just call this stage 1. We start with the easy one first, stage 1, and then let's call this one stage 2, and this one stage 3. Okay, so for stage 1, since there's no acceleration, so it can either be constant V or at rest. Okay, 2 possible scenarios like mentioned just now. And this one would be accelerating. This one will be decelerating. Let's look at only this one. We analyze the forces acting on the person in an elevator. So first you have the mg, and then you have the reaction here. We're looking at the person inside. Okay, so you have mg and then you have reaction from the floor. Now, if it's moving upward at constant velocity, that means acceleration, we know it is 0. Okay, so if acceleration is 0, what happened to the resultant force? Resultant force is also 0. No acceleration, no resultant force. So if no resultant force, what does it mean in terms of these two forces, R and mg? If no resultant force, that means these two are balanced. Okay, so we can write R equals to mg. Here we get. So what can we say about this one? When the elevator, or it can be applied to anything, like a string hanging a mass, or anything that is moving up or down at constant velocity, the reaction is always equals to the mg. That is the first one. Okay, so reaction is your weight. It can be moving upward or downward. The keyword is at constant velocity. Okay, so the question, how they ask you, they say, okay, this lift is moving at 5 meters per second, upward, constant velocity. What is the reaction? Find the reaction. Then you know the reaction is equals to the mg. Okay, or if it's moving down, it's the same. Or rest also. Okay, because this one can apply on constant v at rest. Okay, now look at the second one. When the lift is accelerating, here, mg and reaction. We label the force first, mg and reaction. Is there any other forces? So you scan through the list, MA, MG, F, T, R. Maybe we have tension up here on the string that is hanging the elevator. But because we are currently focused only on the person, the forces acting on the person. Okay, so we only label the R and mg. Okay, if the lift is accelerating upward, there is a positive acceleration. So if there's acceleration, what does it mean in terms of the resultant force? Resultant force is not equal to 0. Then if it's not equal to 0, where is the resultant force? Again, how do you calculate resultant force? Bigger force minus smaller force. Which one is bigger, R or mg? You don't know the value, right? But which one is bigger if it's accelerating upward? 如果我讲 let's say 我这边有一个 object， 这边是10 Newton， 这边是2 Newton。你找 resultant force 的时候，你是把大减小，对吗？所以你用10减2，你拿到8 Newton。resultant force act 在哪里 ？upward。所以如果 resultant force 8 Newton upward， 这样你的 acceleration 在哪里？也是上面。那如果我现在我调转那个问题，我不给你这个10跟这个2，我只是给你2个 force 罢了。我讲这个是 R， 这个是 mg。然后我跟你讲，它是 accelerate 上去，哪一个比较大 ？R 一定是大过 mg 嘛，对不对？你的 R 就是讲10，你的 mg 是2，因为你看那个 acceleration 的 direction 来看哪一个比较大，所以如果它是 accelerate 上去，意思说你的 resultant force 一定是指上去的。怎样有 resultant force 是指上去的？就是你的 R 一定要大过你的 mg。OK， 因为如果 mg 大过 R， 它的 resultant 就是去下面。OK 啊，所以 the point is you look at the direction of the acceleration. Okay, let me write this down. Direction of acceleration. Look at direction of acceleration. Okay, now continue from here. 所以 resultant force 我知道它是 upward. Okay， 意思就是讲 R 是大过 mg。 如果我现在用 Newton second law，F 等于 ma， 我可以 form 一个 equation 出来，我们叫做它是 equation of motion。OK， 怎样 form？ 就是我从 Newton second law F 等于 ma， 这个是 net force 啊，这个是 resultant 啊，所以我可以把这个写成 R 减 mg。OK， 因为你的 resultant force 就是10减2嘛，所以就是 R 减掉 mg， 所以我写 R 减 mg 等于 ma。OK， 然后我 arrange 一下，我拿 R 等于 ma 加 mg，then I box this. What can you say about this equation? mg 是你的 weight，OK， 你的 mass 乘 gravitation acceleration， 你的 weight。所以本来如果它是走 constant velocity 的话，这个两个是 equal 的。如果它是 accelerate 上去的话，你拿到什么 ？mg 加 ma， 意思说它这个 r increase 了。然后刚刚我们讲到 r 是你感觉到你自己的 weight， 所以如果你的 r increase 了，意思说 you feel that you are heavier right now as the elevator accelerate. Okay, and you can calculate what is the r here if you know the acceleration and your own mass. All right, let's look at stage number 3. This one. Stage number 3, you're moving upward, but you are decelerating. mg r. OK， 你的 direction of motion 是向上，你的 acceleration 是哪一个 direction？ acceleration negative 对吗？ acceleration negative， 意思说你的 acceleration 是向下。Be careful with the direction. So if your direction of motion is up and your acceleration is downward, what does it mean? That means you are decelerating. If your acceleration is the same direction as the direction of motion, you are accelerating. If it's different, then you are slowing down. Okay, huh? So that means here acceleration is negative. Do we have resultant force? Yes. So resultant force is not equal to 0. Where is the direction of resultant force? Same with the acceleration. So resultant force is downward. If resultant force is downward, which one is bigger? mg is bigger than r. That's how you create resultant force downward. So mg will be bigger than reaction. Now, put it in the Newton's second law, F ma. The F is resultant force. So the resultant force is calculated by taking mg minus r on the left-hand side. The right-hand side, you just copy down the same thing, ma. Okay, 然后 rearrange 一下 r minus r equals to ma minus mg. R will be equals to mg minus ma. So we get this. You see the r from the equation, the r is the mg minus the ma. So it becomes smaller. The reaction becomes smaller than the normal value. So when you when you decelerate, okay, you decelerate, you're moving up, but you decelerate. your R actually decreases in value. And if you accelerate upward, your R will become bigger. You feel heavier. And if it's moving at constant velocity, you feel like the normal weight. Okay, so if you put a balance, the weighing balance, you put it in the elevator and you stand on the balance, you see the elevator when it's accelerating, constant, decelerating, the meter will, the pointer will keep changing because the balance is reading the reaction force. Okay, right? So here, from here, when you, like I mentioned just now, when you jump out of the airplane, what is the acceleration? You jump out of the airplane, you're falling under gravity. So you have your acceleration will be equal to the gravitational acceleration. That's 9.81 meter per second square. So R equals to mg minus mg. Here, mg minus mg, what is your R? 0. So when you're falling, your reaction is 0. How do you feel when your reaction is 0? You feel nothing. You feel weightless. That is the how weightlessness comes. Okay, so weightlessness is because your reaction changes and your reaction drop to 0 in that situation. What situation? The free fall situation. Okay, so reaction is 0. And this gives you a very strange feeling, right? So many people, they like this feeling, the feeling of weightlessness. That's why they go for bungee jump, they go for skydiving, they go for roller coaster. Okay, all this, there is some feeling of weightless. Because since we were born, right, we are always pressed by the ground. You are always on the ground. You never felt the feeling when you are off the ground. So the moment you feel it when you're off the ground, you feel very strange. You feel very scary at the same time. Some people, they get excited. Okay, some people, they look for the excitement of this feeling, accelerating, experiencing the acceleration of the gravity. Yeah, right. So that is a short one on the elevator lift problems. Now here, you see, I have written some of the equations, right? You have this, the one that I boxed, this one, this one, this one. Now, I don't want you to memorize the equation, no. Remember how the equation is derived rather than memorizing the equation. Okay, you have to understand, how do I get this? How did I get this? How did I get this equation? The process. Okay, understand the process. Why? Is because when you understand the process, you know how to apply in different situations. Because not only the elevator problems, they are very similar problems. If I change the context, I can say a string hanging an object. If I pull up or release, the same thing can be applied there. Or it can be like hot air balloon going up, going down. The same principle can be applied there. What is different? Only the force is different. For in the case of the hot air balloon, you still have mg, and the upward force would be, instead of the reaction, the upward force would be the upthrust, right? Upthrust, or for the string, then you have tension, but the principle still, it is there. the process is still the same. Now I will show a few examples, okay, how to solve it. A few examples of the questions. How will the question answer? Okay, I give you 10 minutes. You can take down something, and I will go to the next slide. Okay, Dana, I will share document here. Okay, a 80 kg man stands on a scale inside an elevator. What is the weight in newtons that the scale reads when the elevator is at rest? Okay, at rest, we use G equals to 9.8. So when it is at rest, forces are balanced. Okay, so R the same as mg. R equals to mg. What is you see the question asked, what is the weight in Newton that the scale reads? The scale read which one? Reaction. Okay, so reaction equals to mg, so 80 times 9.81. .8 Newton. B. When the elevator is moving upward at constant speed of 5. When you see the constant speed, then you know, okay, force must be balanced. R and mg. From just now the example, this is like stage 1, right? Stage 1. So either constant or uniform. So again, we use the same, R equals to mg. Okay, so you don't care about the speed. No matter how fast it moves, it's the same thing. The reaction does not change. So R equals to 80 times 9.81. Same answer with the first one, 784.8 Newton. C, moving downward at a constant speed of 8. Does the reaction change? No. Right? So again, mg r. If you move downwards with constant speed, acceleration is 0, resultant is 0. So r equals mg. Same answer, 784.8 Newton. Okay, D, moving with an upward acceleration of 3. Okay, first label the force, mg, r. And then you look at what? You look at the acceleration, moving with an upward acceleration. So label acceleration up. If acceleration up, resultant force up. If resultant force up, r bigger than mg. Okay, so if r bigger than mg, then we put it into F equals to ma, r minus mg equals to ma. And then we do r equals ma plus mg. Yeah, so we can do r equals to m a plus g at. Acceleration is 3 plus 9.81. (1024.8 Newton). Okay, previous is 784. Now it is experiencing 1024. Okay, E. Moving with downward acceleration. Acceleration down. OK， 所以我刚刚有讲到你要 label 先嘛，对不对 ？F 等于 ma mg ftr， 所以这个是我们 label 了 a is ma 啦 ，OK same acceleration， so you label acceleration, you label the r, you label the g. Is there any other tension? There's no tension, no tension, no friction. Okay, so all these three. After you label, then you put it in the FMA. So resultant force is downward. F ma is mg minus r equals to ma. (80 然后9.81减4464.8。Okay, let's look at example 2. Okay. Let's say we have a hanging mass. And the question asks, find the tension if a body raised with acceleration 5 meters per second squared. If I raise the body with an acceleration of 5 meters per second squared, what is the tension at the string? Okay, step one. What do we do? Analyze the forces. Okay, so we draw the diagram again. And then we look at how many forces acting on it. MA, is there MA? Yes, new acceleration 对吗? Raise with A 5, 所以 A 是上面 5. Okay, after label MA, MG. We have MG here. Let's do 10, so 15 Newton. F, this is friction. Is there any friction? No friction, so skip this. T, tension. There is tension. Okay, there's tension on here. How do you label tension? The way we label tension is to label on the string. So this is the string. We label the arrow on the string, and this arrow is always coming out of the object. Okay, so this is our object here. And we put an arrow that is like coming out of, pointing away from the object. So this is how we label tension. Put a tension here. Where does tension come from? It's like when you stretch the spring, right? You stretch the spring, there's a little bit of elasticity. So the molecules in the string, they try to resist. They try to resist you. So you stretch the molecule away, they say, no, I want to be like this. I don't want to be like this. So you're stretching it like this. So it wants to come back. Okay, so the trying of comeback is what gives you the tension. Okay, so we have tension here. So if you have two objects, let's say separated by a string like this, how do we label the tension? The tension is, again, imagine like you pull them apart. So you have tension here coming out of this object, right? You can see the arrow coming out of the object, and another one over here coming out of the second object. So the arrow is like this. Yes, we got two on one string. We got two tension, but the tension is going to be the same because it is the same string. Okay, this is how we label tension properly. In other words, we say that we label the tension inwards. That means they are always pointing inwards. Okay, back to this one. MA, MG, FT, and reaction. Is there reaction? There's no surface, so no reaction. Done. After you label everything, what do I do? Look at the direction of the acceleration. Okay, so going up, that means my resultant force is upward. That also means the tension must be bigger than the mg. So F equals ma. Resultant force is calculated by taking the bigger minus the smaller, equals to ma. So T equals to ma plus mg. Okay, so you see the process of coming to this over here. Okay, so understand the process. Don't just memorize the equation. right? So T equals MA plus mg, then we just calculate lah, 5, and acceleration is 5 plus 10. Okay, 15. This one we get 75 Newton. This is that much force is acting on the string. If you pull it up, you're not just pulling like this, you're actually accelerating as you pull. So it's like you're pulling faster, faster and faster like this. It is experiencing a force of 75 Newton. Okay. B. Body lowered with acceleration of 5 meters per second square. Now, again, we draw the diagram. So acceleration downward, you have mg, and you have, oops, sorry, this one should be the object. Yes. Lowered with acceleration 5. Where is the direction of motion? Direction of motion is downward, and acceleration is pointing also downward. So it is accelerating downward. Okay, if it's accelerating downward, resultant force is downward. So mg bigger than t. Now you can even do it yourself. Mg bigger than t, so F equals to ma, mg minus t equals ma. So minus t equals ma minus mg, and t equals to mg minus ma. We do the 5 over what is this, 10 minus 5. So this is 25 Newton. What if the question says is moving at constant velocity, up or down? Then R equals to mg. Okay, so R would be 5 times 10, 50 Newton. This is when it is moving at constant v. Whether be it up or down is also 50. You compare the 3 values that we get here. This one we get the highest. This is the lowest. What happens here? When it is accelerating upward, it gives the highest tension. Just like the elevator, when it is accelerating upward, it gives the highest reaction. So usually when the string snaps, it usually snaps when you are raising it. Why? Because when you raise, that is where the tension is the highest. So the string tend to snap as it is accelerating upward compared to if you lower it. Yeah. So here, if I say that, let's say the question they ask, okay, the maximum stress can be withstand by the string, meaning that the maximum force of the string, it can hold up to 100 Newton. At what acceleration can you accelerate this one without the string snapping? Okay, again, if the maximum tension of the string is 100, then what is the maximum acceleration possible before the string snaps? Right, then you can do the same thing. T equals to ma plus mg. T, this one we put the 100. 100 equals to 5. Now we are finding the acceleration. Plus 10. Okay, so 100 equals to 5a plus 50. So 50 equals to 5a. 10 meters per second squared. So this is the maximum acceleration. It can go before the string fail. Anything higher than that one, the string snap. Okay, you take this down and we go to the next example. And before that, I give you a 5-minute break. And then we come back. I'll show you another 2 more examples. Then I give you some exercises. Right, so 5 minutes. So we'll come back at 5:35. OK， 我们回来。All right. Example 3. Let's say we try a different one. Okay, question says find the tension. Find the tension on both the strings. On both strings. Okay, how do we do this? Come back to the first, recall back. What is the first step? In any of the questions, like finding tension, finding acceleration, or just finding the reaction, okay? They're all the same based on Newton's second law, F equals to ma. So the way you analyze this, the problem is the same. Step 1, identify all forces. Okay, identify all forces. Okay, so how many forces we have here? Let's go through the list. What is our list? F 等于 ma. 有 acceleration 吗？没有，所以 A 没有 cross out。mg 有 mg 吗？ Yes. So I'm going to call this m1g and this one m2g. Okay, label on the diagram. Third one, MAMGF. Friction, there's no friction. T, tension. Yes, we got tension. How many strings we have? 2, right? One on top, one at the bottom. 2 string and 1 string. The way you label tension, how do you label? You label inward, right? You label inward. So we draw arrow inside and inside like this. Now this is on the same string, 同样的一个 string， 所以我们用同样的 symbol， 我们叫它 OK， 因为这个 M1， 所以我们叫它 T1 T1。Okay, you can see this arrow is coming out of this object. This arrow is coming out of this object. And then we got another string here. So we label T2 and then another one here, T2. Okay, so this one done, done, done. MAMGFT. Okay, 我们有这个 R. 有 R 吗？没有 R. Okay, that's it. Now already I have all the forces. The next step, look at acceleration. Is there acceleration? Now we want to, what we want to find, the purpose is we want to find the tension, right? Okay, so to find the tension, first you need to get the equation of motion. Equation of motion. 什么是 equation of motion? 就是刚刚我们 derive 的全部那种 equation. OK， 你的那个什么 T 减 mg 等于 ma， 这种就是 equation of motion. OK， 或者 R 减 mg 等于 ma。我们首先要拿到那个 equation of motion 先，我们才可以 solve 那个 unknown。所以如果你要拿 equation of motion, then we look at the resultant force, right? Acceleration 是0，这样 resultant force 什么 ？OK， sorry， 我忘记有一个 step， 就是你看啊， 哎 ，Royston 又 join 进来，他的 internet 不好。OK， 那首先你看啊，这个跟之前那个不同，是因为这个有多了一个 object。OK， 我们这边有2个 object。2 kg and 5 kg， 在刚刚我 show 你的全部 example， 我们只是 deal with one object, one body. So if you have 2 body, you have to analyze separately. Okay, you see after I label the force already, right? My second step is I want to draw a free body diagram. FBD. This is the free body diagram of 2 kg. 一个 body 一个 diagram， 2个 body 你有2个 diagram， 所以我们先画2 kg 的这个。那怎样画你的 free body diagram？ 我们只是拿这个2 kg， 还有它的周围的 force 罢了。你看啊 ，from 这个 diagram 啊，我切这边出来，这边，然后我拿买这个 T1， 你的 tension 要 include 啊，因为你有那个2条 string 嘛，一个是上面，一个是下面嘛，你要 include 那个 tension。OK， 所以我的 diagram 变成这边是2 kg and we got tension 2, we got tension 1. What else do we have? We have the mg m2g. OK， 我拿这个出来，我把它弄成 free from the diagram. Initially it's in the diagram, I take it out, I make it free. That's why we call it free body diagram. Now, after I get the free body diagram, then only I analyze based on the resultant force. OK， 有 acceleration 吗？没有，零。我们又回来那一个 process， 没有 acceleration， 这样我的 resultant force 是什么 ？resultant force 是0咯。如果我的 resultant force 是0，代表什么？上面的 force 等于下面的 force。你这边有3个 force 吗？所以 T2 等于 T1 加 M2G。OK， 刚刚那个 lift 的那个问题，你只有2个 force 罢了 ，R 跟 mg。如果你的 acceleration 是0，这样你的 R 就等于 mg， 上面等于下面。这个你有3个 force， 所以我写 T2 等于 T1 加 M2G。这个就是我的 equation of motion. We put it number 1 because we have another one. Okay. If you're not following, let me know in the chat. If you have any question that you want to ask, just feel free to ask and stop me anytime. Okay, let's continue. FBD for 5 kg. OK， 我们拿只是5 kg， 这边我拿 T1， 帮我买这个，所以我只是 T1 and then we have M1G. Only 2, only 2. What is acceleration? Again 0. So F resultant 0, then T1 equals to M1G. That is equation number 2. Now, once we have the equation of motion, we solve it. We can find T1 equals to M1 is already given 5 times 10, 50 Newton. T1. Okay, put it inside here. 50 plus 2 times 10. So 70 Newton. 那个是我的 T2. I have found the tension T1 and T2 using Newton's second law. Okay, so always label the forces first, and then you analyze. If you have 2 body, you need to have 2 equations of motion. If you have 3 body, then you got 3 equations of motion. If you got 1, then just 1. like example 1 and example 2. Okay, example 3 here, you got two body. And what if I say I pull this whole thing so that everything accelerate at an acceleration of 2 meters per second square? Then you do the same. If the whole thing is accelerating, all the process here is the same, just that the acceleration here, we would take A equals to 2 meters per second square upward. So then you have a resultant force, and then you have to adjust a bit your equation of motion. And for this one, again, the acceleration is 2 meters per second square. Because 如果那个整个 system 是 acceleration 是2的话，不管是这个 body 还是这个 body 啊，它们的 acceleration 都是一样的。OK， 不可以是不同，因为它们是 attach， 它们是一起，这个走几块，这个就走几块了。OK， 所以它们的 acceleration 是 common，they share a common acceleration。除非他讲那个 string 是可以 extend 的，或者 contract。OK， 所以如果这个走这样快，然后它这个没有直接走，它可能它的 string 可以 extend 一下它才走啊，这样子的情况下，你的 acceleration 就是不同。Okay, so that's why in some question you will see that they say that the string is inextensible. You cannot extend the string. So string is inextensible. That means this is saying that whatever this one is moving, whatever acceleration this one is moving, this one has the same acceleration when the string is inextensible. Okay. Okay, I give you one more. You try it yourself, this one, and we look at the answers after that. Example 4. Yeah, before that, you take down the example 3 first. Now. Okay, you try this. Write down the equation of motion for M1 and M2. Okay, so we want to write this one like this equation here, equation 1 and equation 2 out. How many bodies you have? You have 2 bodies, right? In that system. So you will have 2 equation of motion. Right, you try it first and I'll show you the answers later. Finish? Okay, let's see the equation of motion for M2 first. So we have labeled the forces on the system. MA, okay, A 已经 label 了。然后我们有 MG，这边是 M2G， 这边是 M1G。MGF, there's no friction, tension. Okay, 所以我们有这个 string。now 你看到这个 string over 那个 pulley is the same string. The string that is run over the pulley is the same string. So the way we label it is like this, just one tension and another tension here. Why is the same T? Because imagine if you stretch out the string without the, just imagine without the pulley. The string is straight like this between M1 and M2. Okay, so the tension is like this, T, T. It is the same string, same tension, and we label inward. So this pulley with the diagram is just like, imagine like you just hang the middle here, so it become like this. Okay, so TT and M1GM. Okay, done. Reaction, no. After you're done labeling the forces, then you want to analyze the free body diagram. So draw the free body diagram for this one. Okay, I'll just box this. I'll just box this. So you analyze this one only for M2. Going up, this object is going up, so resultant force is upward. If resultant force is upward, which one is bigger? Tension bigger than M2G. 所以我把它画成 F 等于 MA, resultant force 是 T 减 M2G 等于 M2A. That is your equation of motion for the first mass, M2. Equation of motion for M1. Okay, M1, then we look at only this body. It is accelerating downward, so resultant force is downward. M1G minus T. M1G minus T equal to M1A. This is equation number 2. Let me box this. So 把它擦掉。Good, so that's our answer. So let's say you want to solve it given that if M1 equals to 8 kg and M2 equals to 3 kg, find t, and acceleration. Find the tension and find the acceleration. So you got two equations, right? How many unknowns? T 是一个 unknown, M2G, OK, 你知道这个 value, M2 你知道 A 也是一个 unknown, 所以你有两个 unknown, 这边也是你有两个 unknown, 所以你有两个 unknown, 两个 equation, 你可以做 simultaneous. So solving these two simultaneous, and you can find the tension and the acceleration. Acceleration, 你可以看这个 diagram 是一样的，因为它也是 attached by one string, right? So this one move this fast, this one also move down this with the same acceleration. Okay, let me solve. Okay, you can solve it and check your answer. Your final answer is 4.55. And T equals to 43.6 Newton.